Salam students. Students, today we are doing the configuration of elements of period 4 from potassium till scandium and then gallium. Okay, the period 4. In the previous, we did the electronic configuration of the elements before potassium. We did that, what the configuration is showing, how many electrons are paired, how many are unpaired, how many electrons are in spherically shaped orbital, how many electrons are in dumbbell shaped orbital, like the way the Cambridge asked the questions, right? Now, I'm going to share the screen with you people, but when I'm sharing the screen, you guys are supposed to like and subscribe, okay? Like and subscribe and share my channel, okay? Yes, we were doing exactly this thing. So, we did the configuration. I will start with the, for example, I will start with the phosphorus. Suppose I have phosphorus. There are how many electrons in phosphorus? First is what? 1s, and then what? 2s, and then what? 2p, and then what? 3s, and after 3s what? 3p. And after 3p, electron will enter into what? 4s. And then electron enter into 3d. Once electron enter into 3d, due to repulsion, the energy of the 4s will be more than 3d, right? But we have to fill the orbital this way, right? Now, since we are doing it for phosphorus, how many electrons? 15. Okay, this is used to find out. First electron enter into 1s, then 2s, then 2p, then 3s, then 3p, then 4s, 3d, 4p, 5s. Right? Look, 1s, then 2s, then 2p, then 3s, then 3p, 4s, 3d, 4p, 5s. Right? We will do 2-3 examples of some random element. Then I'm going to do it for potassium till zinc and gallium. Zinc, gallium, and germanium. Like my main thing is this, that we are going to do for these, right? But for potassium, for phosphorus, 15 electron. 1 electron here. What about second electron? It will pair up or it will go in the 2s. It will pair up. It will prefer the low energy, although it is repelled. Like the second electron know that I am repelled, but it will not go to the high energy orbital, right? So it will prefer the low energy. And now when there is no space, the third will go to 2s. The fourth will pair up. Fifth, and then sixth single, seventh single, eighth pair up, ninth pair up, 10th pair up, 11th, high energy, 12th pair up, 13, 14, 15. So 1s2, 2s2, 2p6, 3s2, and 3p3. How many electrons are paired electron? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 are paired, 3 are single. Right? Now, next, if I do it for another element, like, like for instance, I'm going to copy this whole thing, and then I'm doing another thing with you people. This way. From where you get this? 1s, 2s, 2p, 3s, 3p, 4s, 3d. This you know from that thing. Look, like you write 1s, then you write 2s and 2p, then you write 3s, 3p, 3d, then you will write 4s, 4p, 4d, and 4f, and then 5s, 5p, 5d, 5f, and then you are going to cross these diagonally. 1s, then 2s, then 2p 3s, then 3p 4s, and after 4s 3d 4p 5s. Look, look, 1s, 2s, 2p, 3s, 3p, and then 4s, and then 3d. But the main point that you must know that 4s and 3d are very close. And exactly the same pattern, 5s and 4d are very close. But in our course, we are supposed to do it up to 4p, like Krypton 36. Now, if I am supposed to do the configuration of this element, hmm, there's another way, but okay, we will do this later on. That is there any other shorter way to do the configuration? Yes, we can do through periodic table, but right now, you know the configuration of phosphorus. You can do it for this. Now, I'm going to start with potassium, right? So for potassium, it's what? Potassium is how much? 19. Potassium is how much? 19. So what is the configuration of potassium? 1s2, then 2s2, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So for potassium, 1s2, my writing is very bad right now. Wait, doing it this way. Potassium. So what is the configuration of potassium? 1s2, 2s2, 2p6, 3s2, 3p6, and then electron is going into what? 4s1. It's 19. Now, potassium 19. The next is what? Calcium 20. So what will happen in calcium 20? Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, sorry, 14, 15, 16, 17, 18, 19, and 20. So it would be what? 20. So what is the configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is calcium. Now scandium. What? Scandium 21. Now in scandium 21, what is the configuration? 1s2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So the electron enter into 3D. Like when there was no electron in 3D, the outermost is 4s. After 3p electron enter into 4s. After 3p electron enter into 4s. After 4s, the electron will enter into 3D. Once electron enter into 3D, due to interelectronic repulsion, the 4s will be about 3D. So how you're supposed to write? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. But you know how you're supposed to write it? This way. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d1. Like after 3p, fill the 4s first. After 3p, after 18 electron, first you will fill the 4s, then remaining electron in 3d. So if we can do it for all, these elements, huh? No, you know how I am going to write these. Wait a minute. Let me do this for you. This much. Okay. Now, listen. What we are supposed to do? You know what I'm doing? I'm going to write it down this way. Although I know energy is increasing, I should write it this way, but if you don't mind, I'm going to write it down this way. Right? Look, potassium, 1s2, and then what? 2s2, and then 2p6, and then 3s2, and 3p6. Right? 18. After 18, 19, 20, sorry, after 18, 4s1. This is potassium. Calcium, 1s2, 2s2, 2p6, 3s2, 3p6, 18, 19, 20. Look, the fourth period is in the process of completion. You can say that like the electrons are entering into fourth quantum shell. Four period, four quantum shell. This is 4s1. This is what? 4s2. Right? Now, scandium, if I do it for scandium, in all these, this is 100% same. No. Wait a minute. Scandium, titanium, same. Vanadium, same. Chromium, the first 18, same. It is same in all these. Up to 18, it's 100% same. Even in this, 18, right? Look, 19. So 18 is this after 3p, 4s1, 18, 4s2, and now 18, 4s2, 3d1, 4s2, 3d2, 4s2, 3d3, 4s2, 3d4, 4s2, 3d5, 4s2, 3d6, 4s2, 3d7, 4s2, 3d8, 4s2, 3d9, 4s2, 3d10, and this 4s2, 3d10. So look, this is how 18, 19, 20, 20 plus 10, 30, and 31. 4 is 2, 4p1. This is what? 4p1. 3d10, 4s2, 4p2. 3d10, 4s2, 4p3. 3d10, 4s2, 4p4. 3d10, 4s2, and 4p5. 3d10, 4s2, and 4p6. Listen, we know that 3d and 4s are very, very close. Yes, they're very close. They're so close. Look, they're very close. And the closeness is the reason. If in an element, this is nucleus, this is kind of, look, this is nucleus, 1s, 2s, 2px, 2py, 2pz, 3s, 3px, 3py, 3pz. And then what? 4s. And then what? 3d. But due to repulsion between 4s and 3d, the 4s is about 3d, but they are still very, very close. They are so close that they are considered to be same shell. And if they are considered to be same shell, look, there's one electron, so group 1. There's 2 electron, group 2. This is 2 and 1, 3. This is 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is group 13, group 14, group 15, group 16, group 17, and group 18. So what you are supposed to know? That after 3p, after 18 electron, first electron enter into 4s, and then electron enter into 3d. Once electron enter into 3d, due to inter-electronic repulsion, the 4s is about 3d. So you have to write 4s, the outermost. Why? When you will make ion, which electron you will remove first? Suppose you are making iron 2 plus. So this is your iron. Will iron lose electron from 3d or 4s? 4s. Iron will lose these electron. How much is left? 3d6. Like, you must know that after 3p, electron will enter into 4s, remaining into 3d. In the 4s, enter the electron first and also remove the electron first. Right. Now, so how we did? 3p6, 4s1. 3p6, 4s2. 3p6, 4s2, 3d1. 3p6, 4s2, 3d2. 3d3, 3d4, 3d5, 3d6, 3d7, 8, 9, 10. And when they're all filled, then 4p1, 4p2. Like, look, these are called S1 element. These are called S2 element. These are P1, P2, P3, P4, P5, P6, P block, P block, S block. And these are what? D block. These are called what? D block. Now, in this whole thing, I made a mistake. Like, you can't say mistake. I have not explained it yet. What is that? The chromium and copper. You know what is happening in this? In chromium and in copper, one electron move from this to this. One electron is moving from this to this. So one electron is moving. How much is left? 1. And how much? 5. And what about this? So I think it's making it messy. Huh? Electron moved. How much left? 1. And this become what? 5. In copper, 1 is left, and this become how much? 10. And this is not only true for copper, for all the element below the, chromium and below copper. Right? So if group 1 are S1, group 2 are S2, group 3 are what? D1, then D2, then D3, then the other one is what? D5, but S1. And with the rest, there is S2. Then again, it's D5, then D6, then D7, then D8. Then is this D9 or D10? D10, S1. And this is what? D10. So these are D block elements. If I share with you these notes, look. Look, hydrogen is what? 1s1. Helium has 2 electrons, 1s2. Then lithium, 3. 1 is 2, 2s1, 1 is 2, 2s2. Then 1 is 2, 2 is 2, 2p1, 1 is 2, 2 is 2, 2p2, 2p3, 2p4, 2p5, 2p6. Now, 1 is to 2 is to 2p6, and then 3 is 1, 3 is 2, then 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. The third quantum shell is in the process of filling period 3. And now, this is what? 4s1, this is what 4s2. Look, what I've written. Once electron enter into 3D after 4s. Once electron enter into 3D after 4s, due to repulsion between 4s and 3D, which are very close, the 4s is above now 3D. So after 3p, it's electron going into 4s, but you will write 4s after 3D. Look, and chromium and copper, kind of exception to exception. Like train yourself that 3p6, 4s2, 3d1, 3d2, then do it this way. And then you must know that in the chromium and the copper, the electron is shifted from this to this and from this to this. Now, the last thing. Now, one thing that you know now, they're called what? S1. They're called what? S2. They're called what? D1, D2, D3. This is not D4. This is what? D5. Then D5 again, D6, D7, D8. This is not D9. It's D10. And this is also D10 with this one. Now, these are P1, P2, P3, P4, P5, P6. Now, look at this. This is period 2. This is period 3. So this is what? 2p5. This is what? 3p5. This is what? 2p4. This is what? 3. Like, if you know the period number, you can tell the exact last subshell orbitals. Now, the next thing, how to write the shorthand electronic configuration. Like this way. You know what is shorthand electronic configuration? In shorthand electronic configuration, write the previous group 0 element and then the rest of the electrons. I don't know what happened to my this. It's not this way. It is neon 3s2, 3p5. Like, you know what are you supposed to do? The previous group 0. Look at this. Look at this. Lithium. Not this. Look. Lithium. Before lithium, which group 0 is there? Before lithium is helium. 1s2. So in the place of 1s2, what you are supposed to write? Helium 2s1, helium 2s2, helium, 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 helium. But in sodium, what are you supposed to write? 1s2, 2s2, 2p6, 10 electron for neon. 10 electron for neon. So what you are supposed to write? Neon 3s1, neon 3s2. Look. Neon 3s2, 3p1, neon 3s2, 3p2, neon 3s2, 3p3, neon and neon and neon. Like the 10 electrons are represented by neon, right? So in the place of 1s2, 2s2, 2p6, what you are supposed to write? Neon and 3s2, 3p1. So what you are supposed to write? Argon. You know, up to 3p6, argon, 3d10, 4s2, 4p1, argon, like for 18 electron up to 3p6, what you are supposed to write, look this way, argon 4s1, argon 4s2. right? Okay, we can do this practice. On a separate page. Let's do one thing. Wait a minute. I'm going to take this clean. Electronic configuration is a bit large topic, right? So it takes time. It takes time. So थोड़ा सा हौसला करना होगा, थोड़ा सा आराम से पढ़ना होगा, कुछ भी नहीं होता. There are so many MCQs on this topic. Okay. Now, in the periodic table, look, it is what? 1s1. This is what? 1s2. This is what? Like now I'm writing the valence electrons. What? Valence electron, the outermost only. And you know how? This is what? 1s1. This is what? 1s2. This is what? 2s1. This is what? 2s2. This is what? 2p. Like, how to write it? Okay. This is what? 1s1. This is what? 1s2. This is what? 2s1. 2s2. 2p1. 2p2. 2p3. 2p4. 2p5. 2p6. Now, 3s1. 3s2. 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Now, 4s1, 4s2, 3d1, 3d2, 3d3. I know at this point when I'm writing 3d4, you will object. It's not 34, but for time being, we are writing 3d5, 3d6, 3d7, 3d8, 3d9, 3d10. Oh, no, I made a mistake. I missed the 3d4, see? 3d4, 3d5, 3d6, 3d7, 3d8, 3d9, 3d10. Now, after this, look, this is 3p, so I will write what? 4p. So it's 4p1, 4p2, 4p3, 4p4, 4p5, 4p6, and exactly the same pattern. 5s1, 5s2, and 3d. Now it is what? 4d1. And this. Now this is what? 4d10. And then it's what? 5p6. You know what is the shortcut? You're supposed to erase all the other except the one which are filled. Is it filled? 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, 4. Like I'm shading the filled. 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, 4 is 2, 3d10, 4p6, 5 is 2, 4d10, 5p6, right? Like, if you know, like, if you're not doing that thing, this one, like this configuration, and the crossing one, like if you're not interested in this one, What is the other method? Like this is another method. The most of the student I've seen that they do this configuration, like they do the configuration using the periodic table, but they know that it is what 1:2. They know that it is what 2:2. This is 2p6. This is 3:2. This is 3p6. This is 4:2. 3d10 4p. Like now, if suppose if in the paper they ask me to do the configuration of tellurium, now how am I supposed to do? I will write tellurium. I will write tellurium. Right? I will write tellurium. This now I will start from 1s. 1:2, 2:2, 2p6. Like in the sequence, 1:2, 2:2, 2p6, 3:2, 3p6, 4:2, 3d10, 4p6, 5:2, 4d10. Now, I know that after 4d10, the next is what? 5p6, but I have to come 2 behind. So it's 5p6, 5p5, 5p4. So what is the configuration? Again, 1:2, 2:2, 2p6, 3:2, 3p6, and now 4:2 the calcium, and now 3d10 the zinc, and now 4p6 krypton, and now 5s1, no, not 5s1, 5s2, filled one, and now 4d10, and after 4d10, 5p6, 5p5, 5p4. Now, what is the next step? Arrange. If you are going to arrange these, what you are supposed to do? 1:2, 2:2, 2p6, 3:2, 3p6, 3d in the arrangement comes before this, 3d10, 4:2, 4p6, 4d before, 4d10, 5s2, and 5p4. Right? So, first shell, second shell, third shell, fourth shell, fifth shell, 2, 8, 18, 18, and 4, 5, 6. This is the configuration. What is the shorthand? What we can do? Which group 0 is before tellurium? After tellurium is xenon. Before tellurium is krypton. So which one you are supposed to write? Before tellurium. So before tellurium is what? Krypton. The krypton is what? 4p6. So up till 4p6. Up till 4p6. What is the shorthand in configuration? Krypton, 5s2, 4d10, 5p4. What? Look. This. 4p6 up to this. So what am I supposed to write? Tellurium, krypton, in the square brackets compulsory, krypton, 5s2, 4d10, and 5p4. But in proper arrangement, it's this way. Krypton, 4d10, 5s2, 5p4. See? Look, I'm repeating this again. Like, suppose if they ask me to do the configuration, which is not possible, I know up to krypton is in your course. Tellurium. 1:2, 2:2, 2p6, 3:2, 3p6, 4:2, 3d10, 4p6, 5:2, 4d10, and then this. But you have to arrange them, write them in order of the quantum shells, and then next point. Shorthand. Before tellurium, it's what? Krypton. So krypton, 5s2, 4d10, and 4p this. That's it. Suppose you want to do the configuration of shorthand configuration of phosphorus. So which group 0 element is, which group 0 element is coming for before phosphorus? Neon. So what am I supposed to write? Neon. Neon, and this is what? Look, I know S1, I know S2. This is neon. This is period 1, period 2, and this is period 3. So, neon, this is 3s1, this is 3s2. 3s2, 3p1, 3p2, and 3p3. Perfect. So, what is neon? Neon is 10. Neon is what? 1s2, 2s2, 2p6, 3s2, 3p3. Right? Can you do the configuration of, suppose, sodium? So what is sodium? Sodium is neon 3s1. Sodium is what? Shorthand. Sodium is neon 3s1. That's it. And if I ask you, what is the configuration of scandium? So what you are supposed to write? Argon 4s2, 4d1. No, sorry, 3d1. This is 3D series. This is 4D series. This is 5D series. And these are F, 4F and 5F. S block, P block, D block, and F. So if I do the configuration of scandium, what is the configuration of scandium? Scandium, shorthand, argon. Argon, this is period 4, 4 is 2, and 3D1. But how you are supposed to write? Argon, 3D1, 4s2. Now the last point, how to find out unpaired electron in an atom. Listen, you know where you can find the unpaired? Where are the unpaired? Are the unpaired electron in an atom inside or outermost? Outermost. You know, in group 1, only one unpaired is possible. In group 2, all are paired. Look, paired. They're all paired, 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 paired. In group 1, one unpaired. Group 2, 0 unpaired. D1, how much unpaired in D1? If it is D1, 1 unpaired. D2, 2 unpaired. D3, 3 unpaired. There is no D4. It's, D5S1 in chromium. How many unpaired? In chromium, it's D5S1, 6 unpaired. And in manganese, S2, 5 unpaired. If it is D6, how much unpaired? Can you tell me? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 unpaired. 7, 3 unpaired. 8, 2 unpaired. Like, look, 1 unpaired, 0 unpaired, 1 unpaired, 2 unpaired, 3 unpaired, 6 unpaired, 5 unpaired, 4 unpaired, 3 unpaired, 2 unpaired, 1 unpaired, 0 unpaired, 0 unpaired, 0, 0, 0. P1, how much unpaired? 1 unpaired. P2, 2 unpaired. P3, 3 unpaired. But if it is P4, 2 unpaired. P5, 1 unpaired. Look, this I have done for you people. Look at this. finding unpaired. In group 1, it's always n is 1, 1 unpaired. Group 2, 0 unpaired. Group 3, D14 is 2. 1 unpaired, 2 unpaired, 3 unpaired, and in chromium. This is chromium. You know, this group 6 is what? Chromium. Sorry. 6 unpaired. Manganese, 5 unpaired. This is manganese. 4 unpaired, 3 unpaired, 2 unpaired, 1 unpaired, 0. And P1, 1 unpaired, 2, 2 unpaired, 3 unpaired. But if it is P4, 2 unpaired, P5, 1 unpaired. There are many questions in your past papers in which you are supposed to count the unpaired electron. And if you are finding the unpaired electron, don't look at the inside of the atom, look at the outer shells. You'll find unpaired over there, not inside that. Right? I hope you understand this. In the next lecture, there's possibility that I may do some past paper question with you people, right? And then I will go forward atomic radius. But if you want to see the past paper question, look at this. Atomic structure, you can go to my website, Chemistry by Zeenat. Over there, I think it's this, numbers 11s. Where are my, it's again O levels. Why? Yeah, this one. These are my topical. Look, these are the topical you will find on my website, and the notes for this chapter are on my website. The only one thing that you're supposed to do, definitely, you have to organize yourself. You have to make sure that you know that you can get a good score, but you have to do practice. First understand, then do the practice. First memorize, understand, do everything, then start past papers. Look, there are 3 topics. Topic 1, 38 MCQs. You are in a position after 3 lectures, you are in a position to do the 38 MCQs. Then in the next, this, and third topic is this. And you can see I've given you such type of periodic table. Look, electron occupying spherically shaped orbital about S. I will, like there are questions about equal number of electron, paired and unpaired electron. Look, how have only 1 unpaired, 3 unpaired, like when you will do the past papers, you will know that why I was focusing on the number of unpaired electron. Ab tak ke liye itna kafi hai. It's sufficient for today. In the next lecture, there is possibility I may go for the practice of these questions, some questions with you people, and then I will go for the next topic, right? The atomic radius. Because in A2, I mainly focus on the concept, because I've seen that the structured questions are easy for you people. But in the MCQs, I've seen that you people do it, but you go for so longer methods, which are not applicable in past paper, in the paper, in exam. In 1 hour, 15 minutes, you have to show your smartness. Like, it's not the thing, the paper you're doing. You have to do paper smartly. Now, like, subscribe, and share my channel. See you. Allah Hafiz.